This video lesson is going to be the first in the 3D modeling of the base in the table lamp project. To get started, we're going to begin by drawing a polygon in XY0. We're going to be making sure it's set to 6 sides, which is a hexagon, and we're going to be setting the length of 4.625, and then these other two numbers, 2.313 and the 4.005, these numbers should be identical as we see on this machine shop pencil sketch. Now, the biggest trouble we're going to face here is creating this diamond pattern, which is the serrations here. There's no quick way to do this. I've modeled this base in 2 different ways, and they both have their positives and their negatives. So what I'm going to do is I think I'm just going to show you what I think is the best way to do the 3D modeling. If anybody doesn't like how I'm doing this and they feel that there's a quicker way to do it, please feel free to get in touch with me, and I'll be happy to do the alternate lesson on how to create the base, and then you can decide what you think is better. So moving forward, we're going to begin standard inch IPT 2D sketch on the XY plane. Polygon, right? Normally you would see the rectangle here, come down here and find the polygon, and make sure that this is set to 6, which is the number of sides on a hexagon. We're going to start at XY0, and again, when you're pulling these polygons or these hexagons, to make sure it's in the correct straight orientation, we don't want it to be crooked like this. Keep your cursor running along X0, right? Don't move it off, so you can kind of slide it like this and then click, and then it should be fine, right? This should be perfectly aligned with this corner should be perfectly in line with X0. So dimension, we're dimensioning. We could dimension from here to here. This is 4.625 divided by 2. I like to come off XY0. All right. Now, let's run a couple of driven dimensions. These dimensions will be driven. So running a dimension from here to here, this over-constrains the sketch, but we get the value of 4.005. This is exactly what we see on the table lamp machine shop sketch drawing on the hub. If I run a dimension from here to here, again, this over-constrains the sketch. This is a driven dimension, 2.313. So we know this hexagon is being drawn appropriately, or it has been drawn and sketched appropriately. So at this stage, we're going to hit Finish Sketch, and we're going to extrude it. And the thickness is listed here. It says note cut stock 3/4 by 4 7/8. Well, this is a machine shop note, but the aluminum cuts at a finished thickness, so 3/4 is our size. So this part, it starts off innocently enough, but it shows its teeth later. So, okay. So we have our hexagon. Now we're going to start with the serrations, which can be a bit of a process. So we know that it's 1/16 deep by 90 degrees, 3/8 pitch. So that means from the center of this serration here to the next one that's what that means. The pitch is 3/8. So that's the center to center spacing between all of them. Now, we're not going to start 3/8 from the edge here. We're going to have to go a little less. We're going to have to make sure that it's about a 1/4 inch away to get this to work out. So I'm going to be proving to you in this exercise that the numbers and the math all works out as I do this. switching back. So we're going to start a 2D sketch on this face. And I want you to draw a line long. I don't want it to be short. And there's a reason. You're better to be safe than sorry. So start somewhere up here and come down like this, right? It's just a sketch. Now, that looks pretty bad. Let's do it again. Another one like that. All right, so the first thing we need to do after drawing these lines is make sure that they're parallel to this edge. So we're going to get a parallel constraint, and we're going to make sure these two are parallel, and then this one to here. So that's going to force these two parallel. That's extremely important. Don't miss this step. After we've done this, we're going to be setting our width for the serration pattern. So we're going to run a general dimension. This is going to be aligned, and it says 1/16 on the sheet, but we really need to make this 1/8. Check mark. All right, now we're going to run a dimension from here to here. This is going to be set to a 1/4 inch. That's what I mentioned just earlier. And we've got this sketch constrained. Now, one thing that we should do with this to be professional is just close it off. Right? This part here isn't so important. But, you know, and if you want to make this purple, right, just lock it, and then it'll be constrained fully, right? It's not really important how long this sketch is. What's important, the reason we sketch it long like this is it has to be able to span the entire hexagon, because we're going to be creating a pattern. And if I just make it from where this top edge to this edge is, and I pattern it, it's not going to be long enough to cut through the entire hexagon. So this is why I've made it long, because as I create this rectangular pattern, I need to be able to make sure I'm cutting through the entire hexagon as I do this. If it's too short, you're going to run the operation, you're going to run the extrusion cut, and then you're going to see when you create the pattern that it's not reaching, and you're going to have to redo it. All right, so we're ready to create a part feature here. So we're going to just go into a isometric view here and hit extrude. Select the sketch. We want to cut it, not all the way through. We are going to go 1/16 deep and hit OK. All right, so that's the start of the first one. Now, the next step would be to create a chamfer, because we're creating a 90-degree pitch here, times 90 degrees. So we're going to go with a chamfer. We're going to set the distance here to be 1/16, and then we're going to come in here, select. We'll orbit this over to the side, and we'll select this side, hit OK. So that's how that would actually be manufactured. It would be a 90-degree cut in the shop. This is how it was done when I built this lamp. This is going, at the time I record this video, this is going back about 23 years now. So we're going to have to create the pattern. Now, do we want to actually do that 9 more times? No, too much work. So we're going to use a rectangular pattern found above the pattern tab. So you select rectangular. And the first thing we're going to do is select the features. So we don't want extrusion 1. We want to select extrusion 2 and chamfer 1. So to get them both, you have to hold Control on your keyboard and then select left-click chamfer 1, and we have them both selected or highlighted in blue. Next, we're going to use, we'll use direction 1. So we'll pick the arrow here, and we'll select this edge. And what it's doing is it's previewing a pattern going the wrong way. So we have to change the direction. We're going to hit the flip. So we're flipping it the other way. And this first row here, where it has these 3 circles, this is number of items. So it's going to do 2. We need 10. But we have to change the pitch. This is where we set our pitch. And we've identified earlier that our pitch is 3/8 of an inch. So 3/8. And we're ready to hit OK. And that patterns the first row. That's pretty quick. That's the easiest way to get all the rest of those in place. Now, there really isn't an easier way to do that as far as I'm concerned. Now, the headache happens when we're trying to create the other way. And I'm going to talk about why this is difficult. So, in theory, why couldn't I just repeat that process here? Right? We know that we have to create another serration coming off this edge. In theory, I should just be able to repeat what I did and pattern it the other way. Well, I can't do that because I found that if I do exactly that, when I try to pattern this the other way, I get modeling errors. Inventor, for some reason, is not sophisticated enough to be able to pattern the crisscross to get the diamond shape with the V groove. It's very, very annoying. So it creates a little bit more work. But we're still going to essentially do the same kind of thing. Now, before we continue, I said that I would be proving to you that the math is going to be working out on this, that we're going to get it all even and correct. Now, let's take a look at what we have. So we're going to tab over to Inspect, and we're going to measure. This is the one I did manually, the first one. So from here to here, it's showing as 0.250. Let's measure this side. 0.255, okay? That's not good. It's off by 0.005 of an inch. So we're going to have to fix this before we continue. So we're going to X that out. We're going to go back to extrusion 1. Now, you don't have to do this. Hopefully you're watching this video and then you're going to do this later. So you can just make this fix ahead of time while you're creating extrusion 2. So we're going back to edit sketch. Whoops. We're going to extrusion 2 in editing the sketch, not 1. End. So we're going to make sure that we're typing 0.2525. That is going to get it totally equalized and balanced on each side. Check mark. And then we're going to hit finish sketch. That's going to update. So let's inspect this once more. From here to here, 0.253. So it won't read that 0.5 thou, which is okay. And then we'll measure from here to here, and it's the same. So this is how it should be. So make sure that this is done as 0.2525, right? I wanted to do it incorrectly on purpose because I didn't want you to have to wonder why I had to be so precise about that number. I think it makes more sense to show this way to you and why I had to fix it. I think you understand that. So the pitch, so from here to here and to here and to here is 3/8. All right, so the pitch is fine. The numbers are working out. So let's start again here. Let's go 2D sketch on this face, and we're going to do the same thing again, extremely similar. So line, we're going to be coming off way out, just like I showed you before, because I want to be able to span the entire hexagon. Do something like this, and then we're going to right click, left click, create line, create another one, and close that off. So what do we have to do now? Parallel constraint. Make these two lines parallel, make sure of that, and then creating a parallel constraint from here to here is going to force all of this completely parallel to that edge. We got to run a dimension aligned. Again, this has to be set to 1/8 or 0.125. And see what it does there? It's very annoying how it shrinks it like that. Right, from here to here, 0.2525. Now that we know that that's what we want. All right. This. Okay. There. Now I know that I'm going to be reaching this. Right? So that's why when it shrunk, if I had continued on from how it had shrunk it down, it would not have reached and cut through the entire hexagon. So that's why I left it, created the dimension from the edge to the start of the serration, and then I went back and I did this dimension. There's a little explanation for you. We're going to lock these two lines. Okay, and we're ready to cut. Finish sketch. Extrude. Cut 1/16. Okay. Now remember, some of you may get greedy and try this. You may create the 90-degree groove now and then try and pattern it all the way and finish this. It will not work. It will give you modeling errors. So don't even try it. So what we can do, though, is we can pattern it the way it is. So we're going to do that. So we're going to go back to rectangular. We're going to select extrusion 3. Flip. We want 10 items, and we want to set the pitch to 3/8. And this should cut through the entire hexagon. And it does. Now, it looks funny because we don't have the 90-degree pitch everywhere like we should. So, but what we can do, let's just check this one as well before we continue. So let's go back to inspect. Let's measure. This is the one that I had just done. From here to here, I got 0.253. And I got 0.253 again. So this is working. All the numbers are working out. It is exactly well balanced. All these diamonds are in the exact perfect position. Now, here comes the part that you may not enjoy, and you have to now manually create all of those chamfers. And so I'm going to begin. I'm going to go chamfer 1/16, and what you're going to do is you start here, and it'll preview this one, and then as you keep selecting, it'll take that preview away, and it just basically is remembering, okay, we have to create that chamfer all along here. And then it will preview them all. and then orbit to the other side, and it's going to do the same thing again. So pick, 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 and then it's going to create a preview for the entire 90-degree serration. So to keep this up, we're going to select here, here. It's going to take it's going to take that preview away. Same thing. It's doing the same thing we discussed. All right, and I'm going to hit OK. And that is the start of it, right? And look, it's starting to look nice, right? It's starting to get that nice diamond serration pattern on the top. Now, you're not going to watch me do all these other ones. I'm going to be stopping the video in a couple of minutes here, and I'm going to let you continue on and do this on your own, because you've seen me do these two. So you might want to split it up over maybe 5 different chamfers, like I did it in a row of 2. So you can do another 4 chamfers here, and then it'll be completed. Now, it's a lot of picking. I get that. Again, if you don't like this method of creating the base, I have another method of doing it that I can show you you don't have to pick every edge here and create the serration pattern like this. But I'm going to warn you though, it comes with other challenges, and so there really is no easy way out. So think about that, and if I hear from you, great. If I don't, that's fine too. So I'm going to be stopping the video here, and I'm going to pick this up after I have completed all my serrations in my base. So good luck, take care, and talk to you later. Bye.